Wow, this is hot.
Yeah? Is it that hot?
This is the hottest river in the world. If you fall into it, you will die or get severe burns. And we...
Deep in the Amazon, a river appears to break one of nature's most basic rules: water that can kill animals within seconds. For generations, locals have known about its terrifying heat, while outsiders questioned whether the stories were exaggerated. Then scientists measured temperatures approaching boiling, far from any obvious active volcano, triggering disbelief and controversy over what could possibly be heating such a massive stretch of jungle water. Is this truly a natural wonder, a geological anomaly, or evidence that something far stranger lies beneath the rainforest? Where the river turns lethal. At first glance, nothing about the river seems impossible. It cuts through the dense Peruvian Amazon like countless other waterways, surrounded by towering trees, thick vegetation, and the constant movement of rainforest life. To an animal searching for water, the surface may look familiar enough to approach without hesitation. That ordinary appearance, however, hides a danger so extreme that a single mistake can become fatal within moments. This is Shanay-Timpishka, a remarkable thermal river deep inside the Amazon. Its most unsettling feature is not simply that parts of it are hot. The greater mystery is that the river does not begin that way. In its upper reaches, the water can be relatively normal, flowing at temperatures around 27 degrees Celsius. It resembles an ordinary jungle stream, the kind of place where animals might drink, cross, or seek relief from the tropical heat. Then the river changes. As the water moves farther through the rainforest, its temperature rises. Hot water enters the system from below, transforming sections of the river into a deadly thermal corridor. The hottest areas can reach temperatures approaching the boiling point of water, creating conditions capable of killing animals almost instantly if they fall into the wrong stretch. Steam can rise from the surface, but the river remains a flowing body of water, rather than a small, isolated pool hidden beside the jungle. That scale is what makes Shanay-Timpishka so difficult to understand. This is not merely a bubbling spring or a tiny geothermal opening. It is a substantial river system extending through the Peruvian Amazon, with sections wide and deep enough to appear like a conventional waterway. Yet beneath that familiar surface lies an environment capable of delivering lethal heat, and that creates the contradiction at the heart of the entire story. Extreme geothermal water is usually associated with volcanic regions, where magma lies close enough to the surface to heat underground water. But Shanay-Timpishka exists far from the kind of active volcanic landscape most people would expect to find behind such extraordinary temperatures. So the river presents a question that seems almost impossible to ignore. How can an ordinary-looking Amazon waterway gradually become hot enough to kill animals while flowing through a region without an obvious volcano providing the heat? The answer may be hidden beneath the rainforest, where the river's visible transformation could be revealing a far deeper process. But before that mystery can be understood, the water itself must be followed downstream, toward the point where an ordinary river begins turning deadly. Yet the river's heat is only the beginning of the mystery. What hidden force keeps feeding this deadly warmth from beneath the jungle? Why does the water remain trapped in this lethal temperature zone? And what happens when something living enters the river's hottest reaches? Let's unravel the mystery. Where the water becomes lethal. Following Shanay-Timpishka downstream reveals a transformation that seems almost impossible to witness in a normal river. The water begins in the Peruvian Amazon as a comparatively ordinary stream, moving through the rainforest without immediately announcing the danger hidden within it. At that stage, nothing about the surface suggests that the same waterway will soon become one of the most extreme natural environments in the region. But the farther the river travels, the more the conditions begin to change. Heat enters the system from below, and the temperature rises as hot groundwater feeds into the flowing water. The transformation is gradual rather than sudden, creating a strange boundary between the familiar and the lethal. One stretch can appear like a warm jungle stream, while another, farther downstream, can release enough heat to make approaching the water extremely dangerous. The hottest areas reveal themselves through clues that are difficult to ignore. Steam can rise from the surface as the heated water moves through the river. The banks may become unstable, and the surrounding atmosphere can feel different from the cooler sections upstream. Yet the river remains a river. It continues flowing through the jungle, wide and deep enough to appear like an ordinary waterway rather than a small pool beside a volcanic vent. That distinction matters because the entire system is often described in the most dramatic terms possible. Shanay-Timpishka is not uniformly boiling from its source to its mouth, and the water is not continuously rolling at 100 degrees Celsius along every section. Its hottest measured areas approach the boiling point, making the river extraordinarily dangerous without turning the entire waterway into a giant boiling cauldron. Paradoxically, that makes the mystery even more compelling. The heat is not spread evenly across the river. It appears in specific zones where underground hot water enters the system and changes what the river becomes. The water is therefore more than a hot stream. It is a moving boundary between two environments, carrying ordinary Amazon water towards sections where geothermal heat takes control. And that raises a far more unsettling question than whether the river is hot. What hidden process beneath the rainforest could heat a flowing waterway so dramatically, kilometer by kilometer, without making the entire river equally dangerous? The answer lies somewhere below the surface, but the river has already revealed the first clue. Its deadly heat is not present everywhere. It is being added along the way. That pattern rules out a simple explanation and turns the river itself into evidence. Each temperature change becomes another clue that something beneath the rainforest is feeding heat into the water. The surface may look calm, but its journey is far from ordinary. The volcano was missing, yet the river burned with terrifying force. So where was the heat coming from? Could an unseen geological system be hiding beneath the forest? And what would Andres Russo uncover when legend finally collided with science, revealing a possibility nobody expected? Let's find out. Where the volcano should be. The first serious problem appears when the heat is placed on a map. For generations, extreme geothermal water has usually pointed investigators toward one obvious suspect: a volcano. Magma deep beneath the ground can heat surrounding rock and groundwater, creating hot springs, steaming vents, and other features that reveal the presence of intense energy below the surface. In many parts of the world, that pattern is so common that volcanic activity and extreme geothermal heat are almost treated as connected by default. That expectation makes Shanay-Timpishka far more difficult to explain. The river lies deep in the Peruvian Amazon, far from an active volcanic center. There is no obvious volcano beside it, no visible volcanic vent announcing a hidden source of magma, and no straightforward explanation that immediately accounts for such extreme temperatures across a substantial flowing waterway. The contradiction was difficult enough to challenge even the people best prepared to investigate it. Andres Russo, a geoscientist specializing in geothermal systems, had heard about the river through a family story. The account described a place where water was so hot that animals could be killed after falling into it. Yet his own professional understanding initially made the claim difficult to accept. The geological rules he knew suggested that a river reaching such temperatures should have a powerful heat source nearby. That created an uncomfortable tension between what the story claimed and what conventional expectations appeared to allow. Perhaps the river had been exaggerated. Perhaps the legend referred to a much smaller hot spring that had grown more dramatic through retelling. Perhaps the entire account had been misunderstood. Those possibilities were easier to accept than a massive thermal river existing where the expected volcanic explanation was missing. But the river was not a recent discovery waiting for an outsider to reveal it. Local communities had known Shanay-Timpishka for generations. They understood its dangerous sections, its unusual behavior, and its place within the surrounding landscape long before modern scientific measurements were taken. The question was never whether the river existed. The question was how outside science would interpret something local knowledge had already recognized as extraordinary. The absence of the expected volcano therefore became the investigation's first turning point. It removed the simplest answer and forced attention toward deeper structures, hidden pathways, and processes operating below the jungle. Once Russo investigated the river, the mystery became impossible to dismiss. The water was real, the heat was real, and the danger was real. Yet the explanation remained hidden beneath the rainforest. The missing volcano did not make the river less extraordinary. It made the central mystery far more difficult. What geological system could produce such heat without the source everyone expected to find? Long before scientists measured its heat, local communities already understood the river's power. Was Yakumama merely a legend, or a language shaped by generations of observation? And what happens when modern science finally confronts knowledge that was never waiting to be discovered? Keep watching. The river's ancient keepers. Long before Shanay-Timpishka became the subject of scientific measurements, maps, and international attention, the river was already known to the people living beside it. In and around Mayantuyaku, the water was not an unexplained rumor waiting for an outsider to confirm. It was part of the landscape, part of daily life, and part of a body of knowledge passed through generations. The communities connected to the river understood that its waters were not uniform. Some areas were safer than others, while the hottest sections demanded caution. The river could serve practical purposes, carry cultural meaning, and hold a place in traditional healing practices. Its importance was therefore not limited to the question of how hot it became. It was woven into the lives of people who had learned to read the landscape through long experience. That knowledge also carried a spiritual dimension. Traditional accounts associated the river with Yakumama, the mother of the waters, a powerful serpent spirit connected to the origin and movement of water. To an outside observer, such an explanation might appear to belong entirely to legend. Yet, dismissing it as simple superstition would miss the deeper reality. The people living near the river had spent generations observing its behavior, its dangers, and the forces shaping the world around them. Their explanation and modern geology do not make identical claims, and they should not be treated as if they do. Science uses measurements, maps, temperature readings, and geological models. Traditional knowledge uses memory, experience, symbolism, and stories that preserve observations across generations. The languages are different, but both emerged from attempts to understand a physical environment that was impossible to ignore. That distinction became especially important when Andres Russo began investigating the river. He did not discover a hidden waterway that local communities had never seen. The river was already known, understood, and respected by the people who lived beside it. What changed was that scientific investigation began translating its extraordinary behavior into measurements and geological questions that could be examined beyond the communities that had long lived with it. This created a more complicated story than the familiar idea of myth being replaced by science. The river had never been invisible. Its heat had never required an outsider to make it real. What scientific investigation changed was the framework used to explain the phenomenon and the audience able to study it. By the time the river entered wider scientific attention, local knowledge had already established the essential fact: Shanay-Timpishka was extraordinary. The remaining question was not whether the river was real, but whether the hidden forces beneath it could finally explain what generations had already learned to respect, fear, and carefully navigate. And if rain can disappear beneath the rainforest, travel through hidden fractures, absorb the Earth's buried heat, and return as a boiling river, what else could be happening far below? Could an invisible geological pathway explain the impossible temperature? And what happens when scientists finally trace where that water comes from? Stay glued. Beneath the jungle, heat waits. The search for an explanation now moves beneath the rainforest, into a world no one can see from the riverbank. On the surface, Shanay-Timpishka appears to be a natural mystery. Below it, however, the answer may begin with one of the simplest facts about the planet. The deeper water travels into the Earth, the warmer its surroundings become. This is the geothermal gradient. Rock becomes hotter with increasing depth, not only beneath volcanoes, but throughout the planet. Extreme geothermal heat, therefore, does not automatically require magma sitting close to the surface. A volcano can provide a powerful route for heat to escape, but it is not the only possible one. In the Amazon, enormous amounts of rain fall onto the forest. Some of that water remains near the surface, flowing through streams and rivers. Some may move downward through soil, fractures, and cracks in the rock. If geological structures carry groundwater deep enough into the Earth's crust, the water can gradually absorb heat from the surrounding rock before beginning a journey back upward. That is where the mystery becomes more intriguing. Beneath the rainforest are deep geological faults, enormous fractures that may provide pathways through which water can travel. The leading explanation suggests that these structures could allow rainwater to descend, warm underground, and eventually return toward the surface through other parts of the fault system. The river above may therefore be only the visible end of an invisible journey. What looks like an ordinary Amazon waterway could be receiving heat from water that has traveled deep through the Earth's crust before emerging through springs and fractures along the river's course.
Imagine a river, hot enough to kill you, said to be the home of a powerful Amazonian water spirit. It's the Shanay-Timpishka, the boiling river of the Amazon.
Yet, the exact underground pathway should not be treated as completely settled. The broader process is scientifically plausible, but the full mechanics of Shanay-Timpishka's system remain a subject of investigation. That uncertainty matters because the river's scale is extraordinary. Rain, faults, pressure, and geothermal heat are individually ordinary features of the planet. Their combination, however, produces something remarkably rare, a large flowing river whose hottest sections approach the boiling point. The mystery, then, may not require an undiscovered source of energy. It may require only the right arrangement of familiar forces. Rain enters the ground. The earth warms it. Geological fractures guide it. Pressure helps move it back toward the surface. Somewhere beneath the jungle, those ordinary processes may be combining in an extraordinary way. The river has already shown what happens when the Earth's hidden heat finds a path upward. The next question is how that underground system actually transforms a normal stream into a deadly one. And if that explanation is correct, the river is revealing hidden machinery beneath the rainforest itself. And beneath that deadly current, could an even larger hidden system be feeding the heat from places no human has ever seen? Could the river's true secret lie deeper than anyone imagined? And what happens when scientists follow its trail toward the source? Stay tuned. The hidden journey beneath. The river's mystery becomes more understandable when the journey of its water is traced backward. Above the Amazon canopy, rain falls in enormous quantities, soaking the forest floor before flowing across the surface or disappearing into the ground. Some of that water may find its way into deep fractures and fault zones beneath the rainforest, beginning a journey that could eventually transform ordinary rainfall into the dangerously hot water flowing through Shanay-Timpishka. As the water moves deeper into the Earth's crust, the surrounding rock becomes warmer. Time and depth allow the groundwater to absorb that heat. There is no need to imagine a hidden volcano suddenly appearing beneath the jungle. The planet already contains enormous amounts of internal heat, and deep geological structures can provide pathways through which water interacts with it. The real turning point comes when the heated water begins moving back upward. Pressure within the underground system, combined with the shape and direction of geological faults, may force the water toward the surface through fractures and springs. When those hot springs enter a cooler stream at multiple points, the river can gradually change character. A waterway that begins at a relatively ordinary temperature can therefore become dramatically hotter as it moves downstream. The river is not being heated by one visible source. Instead, its temperature may be the result of several underground inputs joining the flow along the way. That possibility transforms Shanay-Timpishka from an isolated curiosity into a window beneath the rainforest. The surface reveals only the final stage of a much larger circulation system hidden below the ground. Every steaming section may represent a point where water that traveled deep into the earth has found a route back into the open air. The image carries an unexpected connection to the traditional association with Yakumama, the mother of the waters. The serpent spirit should not be presented as a scientific prediction of modern geology. Yet the image of water moving through a hidden force beneath the landscape can seem striking when placed beside the possibility of a deep underground system guiding hot water toward the surface. That resemblance does not erase the differences between traditional belief and scientific explanation. It simply shows how the same landscape can be understood through very different systems of knowledge. The larger revelation is even more powerful. Shanay-Timpishka may not be an isolated miracle or a strange pool created by an unknown force. It may be the visible result of rain, pressure, fractures, heat, and gravity working together in an unusually effective arrangement. The river's surface only shows where the hidden journey ends. Somewhere beneath the jungle, the deeper process continues, and its next secret lies in understanding why this underground system can make ordinary water so deadly. And that is what makes the river so terrifying. Danger can hide beneath water that looks completely ordinary. So how do local people recognize the places animals cannot? What happens when scientists finally trace the source of this impossible heat? Stay with us. The river's most deceptive danger. The most disturbing part of Shanay-Timpishka may not be the steam rising from its hottest sections. It may be the fact that, from an animal's perspective, the river can still look like a river. There is no obvious barrier separating safe water from lethal water, no warning sign written into the landscape, and no predator waiting beneath the surface. An animal searching for drinking water, cooling relief, or a route across the jungle may approach the edge without understanding what lies ahead. That danger is not spread evenly across the entire system. Some sections are far cooler than others, while the hottest zones can reach temperatures capable of causing catastrophic thermal injury almost immediately. The difference between those areas may be impossible for an animal to understand before it is too late, especially where heat enters the river from underground springs and changes conditions without obvious warning. The reason the water is so dangerous comes down to basic physics. Water transfers heat far more efficiently than air. A person can tolerate temperatures in a hot environment that would become extremely dangerous through direct contact with water at the same temperature. Water carries heat directly across the body and remains in contact with the surface, allowing energy to move rapidly into living tissue. For animals, the problem is even more severe because their normal behavior does not account for a river like this. A stream is usually associated with drinking, cooling, or crossing. The water may appear to offer exactly what an animal needs, while the heat hidden within it creates an entirely different reality. The river itself is not attacking anything. There is no deliberate trap, no mechanism waiting to capture animals, and no intention behind the danger. The threat comes from an ordinary instinct meeting an extraordinary environment. A creature behaves exactly as it would around a normal river, only to encounter water whose temperature can turn that familiar setting into a deadly hazard. Yet the danger is not equally mysterious to everyone. The people living near Shanay-Timpishka have known its dangerous zones for generations. Their familiarity with the river allows them to understand which sections require caution and which areas can be approached safely. That knowledge makes the river even more unsettling. Its danger is real, but it is also uneven and deceptive. The same waterway can appear ordinary in one place and become lethal farther along its course. For the animals that cannot recognize the difference, the river remains a hidden threat. And that raises a deeper question. If the danger is invisible until contact, how many secrets might the rainforest still be hiding beneath its familiar surface along the same course? And what happens when the rainforest begins losing its ability to feed the sky, the soil, and the hidden water beneath it? Could the river's ancient heat survive while everything around it slowly changes? And who will decide whether conservation or survival comes first? Keep watching. The river depends on rain. The mystery of Shanay-Timpishka does not end beneath the ground. Its future may also depend on what happens above it, across the rainforest that surrounds the river. The same jungle that hides the thermal system also helps supply the water that keeps the region moving. If that forest changes, the consequences may reach far beyond the trees themselves. The Amazon is not simply a landscape that receives rain. Through evaporation and transpiration, the rainforest constantly moves water back into the atmosphere. Trees draw moisture from the ground and release it through their leaves, helping maintain the cycle of clouds and rainfall that makes the region so wet. The Shanay-Timpishka River depends on a natural water cycle in which rainfall replenishes underground water before heat brings it back to the surface. Scientists believe the concern is not a single event, but the gradual disruption of this larger interconnected system over time. This does not mean that cutting down trees would instantly make the boiling river disappear. The heat beneath the ground would remain, and the geological structures feeding the system would not simply vanish. But changes in rainfall, soil conditions, and groundwater movement could affect the water cycle that helps sustain the system over time.
This is even more unique. It's water that comes from the bottom of Earth. Geothermal heating, 100% natural, and the deforestation of the Amazon.
That makes deforestation a more complicated threat than a simple battle between villains and victims. Forests may be cleared for timber, farming, and income, often in places where people have limited economic choices. At the same time, conservation depends on land rules, enforcement, and practical reasons for keeping trees standing. Without those protections, immediate economic needs can outweigh long-term environmental consequences. The contradiction is uncomfortable. The rainforest may be protected not because everyone values it in the same way, but because certain rules and incentives make protection possible. Where those systems are weak, the forest can disappear piece by piece, changing the conditions around the river slowly and quietly before the damage becomes impossible to reverse. And beneath it all, Shanay-Timpishka remains connected to the landscape above. Its heat may come from deep within the earth, but the water carrying that heat still belongs to a larger cycle. The river is not an isolated wonder. It is one visible part of a system linking rainforest, rainfall, groundwater, geology, and time. If that system begins to change, the river's future may become another mystery the Amazon has yet to reveal. The river may not be the mystery after all. What hidden forces keep its deadly heat alive beneath the Amazon? And what happens when the rainforest around it begins to change? Could this ancient wonder be warning us about something far larger than anyone expected? The heat beneath everything. By the end of the investigation, the most obvious mystery surrounding Shanay-Timpishka has become the least satisfying one. The river is real. Its extreme heat is real. Animals can enter its hottest sections and suffer fatal thermal injuries within moments. Yet the expected volcano, the explanation most people would instinctively search for, is not there. The contradiction that first made the river seem impossible remains the key to understanding why it matters. The story began with disbelief. Andres Russo had heard about a river in the Peruvian Amazon that could kill animals with its heat, but conventional geological expectations made such a claim difficult to accept. A river approaching the boiling point seemed to require an obvious source of intense underground energy. When investigation showed that the phenomenon was real, the question changed. The problem was no longer whether the river existed, it was what kind of geological system could create it. The likely answer does not depend on a completely unknown force or a new law of nature. Rainwater can move downward. Gravity can pull it through fractures. Deep rock becomes warmer with depth. Pressure and geological structures can help move heated water back toward the surface, where hot springs may feed the river. Each part of that chain is ordinary. The extraordinary result comes from the way those ordinary processes align beneath the Amazon. That explanation does not mean every detail of Shanay-Timpishka's underground system has been completely solved. The precise pathways of the water and the full mechanics of the geothermal system remain important scientific questions, but the broader picture is powerful enough to change the way the river is understood. What looks supernatural from the surface may be the visible expression of familiar forces operating in an unusual arrangement. And the river was never waiting for science to make it real. Communities around Mayantuyacu and the surrounding region had known its dangers and importance for generations. Long before scientific attention reached the river, local knowledge had already recognized that Shanay-Timpishka was extraordinary. That is what makes the final image so unsettling. Deep inside the Amazon, a river can become hot enough to kill animals, not because a hidden volcano must be burning beneath it, but because rain, rock, pressure, and the Earth's internal heat have found an extraordinary path through the landscape. The river may have existed for generations, but the rainforest around it is changing. The heat beneath the ground may endure, The water cycle that helps connect the sky, forest, and hidden geology may be more vulnerable. Shanay-Timpishka is therefore not merely a strange river. It is a visible reminder that forces beneath the entire planet can remain hidden until the landscape reveals them, and that even ancient wonders may depend on a world that is no longer standing still. So, what do you think? Is Shanay-Timpishka nature's most terrifying hidden wonder? Or proof that Earth still holds secrets science cannot fully explain? We'd love to hear your thoughts in the comments below. Don't forget to like, share, and subscribe for more mysteries.